Thank you, Ravi. Good afternoon, everyone. I know it's getting a bit later in the day, and thank you for being here. So thanks, Ravi. So I'm the founder and CEO of Sparkflows, and before this, I spent 10, 12 years at Cloudera, Yahoo, and eBay, as it said. So today, I want to discuss self-service of Apache Spark structured streaming applications and analytics. Initially, we worked with, of course, D-stream senders, and now everything on structured streaming. Before this, you guys joined, we were taking the time to discuss what are people's interests and things like that. Things came out that, do people adopt self-service? Some questions were, what are the performance implications? Some questions were around administrative challenges associated with it. So welcome again. And I want to ask a quick question. So how many of you are building self-serve applications for your organizations? OK. So that gives an idea. So the goal here being so that you can leave here with some things that you got answered or learned. Would love to share my experiences and learnings. So of course, there are very many use cases around streaming applications, whether it is IoT analytics or fraud detections or anomaly detections or data center automations. So there's so many different variety of use cases around streaming. And so then the question is, why self-serve? Why would you do self-serve? We were discussing before here, there's no one answer. You may do self-serve or you may not do self-serve. And probably you will do both, right? So there's certain advantages of self-serving that you get. You can build those and test those applications quickly, right? You could say, hey, I want to read from Kafka. I want to parse my data this way. I want to do these transforms. I want to load this ML model, and I want to save it. And if I have used it for a good enough self-serve application, then I can build it in a minute, right? And as we all know, and then deploy it, right? Minute or 2 minutes, right? So that is one advantage, right? The other is easier debugging, right? One of the questions comes is, hey, if it is self-serve, debugging would be harder, right? But there are certain things that you could do to make debugging easier. Like, for example, if there are error cases, right? For example, if there are bad records, what do you do? Good records go here, bad records go here, or killed applications on bad records or not. So handling those are not easy to do. Whereas if you write it once and use it many times, that gets simpler. Easy operationalization, so that what if you don't have to compile, set checkpointing, this and that? What if you could say one click, start running it and producing results? So the operational, and what if it can track its status more easily, that you could go somewhere and see what's the status, running, stopped, or killed, or what's the status, right? If you could easily, or you could see all of the previous runs of a flow of your applications, right, in one place. So those things make it easy to operationalize. Visualizations, right? And the streaming, how do you look inside streaming jobs? Suppose you have logs with exceptions coming in, and suppose you have 5 different kind of applications, and you want to have a chart which is streaming at any given time, how many exceptions are being seen in the last 5 minutes, right? And you want to see it visually. So building those visualizations are hard, right? And you want to suppose you want a moving streaming chart with time, right? So it's not very easy to build from scratch. And there are lots of things that you will not have with self-serve, right? So that's why both of, in my learning and thinking, is both of them have their own pros and cons. And it's use the right thing for the right place. It's just an example of what could be, find delayed flights, right? Suppose you're reading from Kafka, suppose it is string fields coming in, and you parse out the fields, certain separator, and then you say a SQL node or processor you have, find the flights which have been delayed by so much in the last 5 minutes, and then you display the delayed flights, and then maybe all of those delayed flights, you save it to, say, a NoSQL store. Or other thing you do is, you aggregate by different airports, and you find per airport what's the status of the flights like, right? How many are delayed? It's just a simple use case, right? So this could be a simple, workflow or a self-serve streaming flow that you could build of value. So want to share here our experiences, learnings, and things. We saved the workflow as JSON, right? So that, and we have put in a jar file so that the interactions will be very quick. And you don't have to manage code and all of those things. So it will take in the JSON and Java, Scala, or PySpark code, pass it in, and then start processing it. And we were different ways. One is how would you build the flows, and you want to have your flows to be very, very powerful. Only then the user will accept it, right? Meaning that things like, we call it interactive execution, where you could see the output at any level of the workflow easily, or you could see the schema propagating through, or you want suppose there's a pull-down field of, hey, I want to plot it by X and Y. Then you shouldn't be typing, what is that X and Y? You should be selecting it from a drop-down, right? Or say, otherwise, if you're doing, say, not streaming, but otherwise, say, logistic regression, which is the label field and which is the feature field, it should be a drop-down, right? So, but then that's the building part, right? Then the other part is execution, right? And you could execute it on, you could have Yarn Spark clusters, you could have Databricks, you could have, running on Kubernetes. So that's the integration part of how do you submit it. So one way this example is showing is to Spark submit, where you see it has a provided jar file, and then the JSON file would be there, and the user, you want to give control to the users to parameterization. Like, you want your workflows to be, or self-serve things to be built that will accept different parameters, right? So that, one could be run with different parameters. And then there are Spark submit configurations, performance configurations that you need to give control to the user. Any questions, things people want to talk? Feel free to ask any question or interrupt at any time. So then the question is, what kinds of processes or tasks or tools that you build out, right, as that you make it available to the users, right? One is connectors. Hey, I want to read from Kafka. I want to read from Kinesis. I need to read from HDFS. You want connectors. You want transforms. Say, I want to transform. I want to parse it. I want to split it. I want to create a new column which is some expression of something else, right? Aggregations, right? Hey, I want to aggregate by this. And then, different kinds of aggregations for reporting others. Then in the flows, you want to allow users to write different kinds of code, like SQL, Scala, Python, and others. So that, I read from here, I write the SQL, and another SQL here, and join these two, and another SQL. That gets powerful, right? So that you're not limited to the processes that are available out of the box. I mean, SQL itself is so powerful, but of course, Scala and Python gets even more. So that you are not so that you can solve the last mile problem, right? You're not limited to some of the valuable processes are like dedupe, right? If you have to do fuzzy match dedupe across two data sets, say using Levingstone algorithm and with different weightage on different columns, it gets complex. What self-serve allows you, I think one of the advantages was to give this complex functionality to the user, right? To write out a dedupe, I would take probably, man weeks to get it really, really well and configured and with great performance. Or say another one we found was data validation. That, hey, validate the email field, this and that, but doing it with configurable way and doing it with great performance, because you're dealing with large data, performance is the thing that comes to your mind, right? Everyone will question it whenever you do a self-serve, is going to suck at performance, right? Unless you can show and actually do, which is better than handwritten in most places, it's not worth using it, right? So the performance has to be the key. And what we found that you end up, or say if you're doing NLP, you have to handle many things like OpenNLP or Stanford NLP you're doing. They are not serializable by default. How do you make it serializable? Not all of those things you can make it happen. And the user has to select, well, I want to do sentiment analysis on this field. I want the results stored in this field, right? So you build it once and you use it many times. So self-serve is a way, I won't think of it as, hey, I'm doing Spark coding this. No, 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 no. It is the main value, one of the value propositions, or I got a question, how do you convince people to use a self-serve, right? So one is it has to be fully secure. Other is that you have to really give higher level features to the user. You have to give the lower level, but the higher level features. If you have a set of columns, you could actually validate different this is social security, this is email, those data validations code get very messy to write for performance. And say if it fails, what do you do, and passes, what do you do, right? Fails, it goes here and store it here, passes, well, those get very, very complex to write at scale. That's what some of our experiences were. And those are when you talk about, then people appreciate. And then if they appreciate the value it brings, then they will do some things with it. This one, it gives you a subset of kind of the things that we went into trying, read different file formats, do ETL transforms, do and do feature generation, machine learning, and those. Let me keep okay. So as we build it out, we build different components. User accesses through the browser. So that makes it multi-tenant, different users can access it and do, so you don't have to install anything, things like that, right? And then talks to your web server, but scalable, so it can scale out, you have many web servers. And then at the top, you have, there's a lot of things, for example, schema propagation or interactive executions that happen inside. And people expect response time of less than a second. Or 2 seconds, or maximum 3 seconds, right? So the Spark jobs have to be up and running, the one that's interacting with, right? So, and then you have to do those interactive on small pieces of data. But another thing is that if I'm doing development on my own, suppose my data set is huge, suppose it's 2 terabytes, right? Then I have to ensure whatever I write that it's not dealing with the whole data set, or it's running very slow, right? So this allows you, this another big feature that, connectors and those when the interactivity, so that it can seamlessly read a few records of different types and take the user to the flow. So that is another very useful feature for the end user as they are interacting with the self-serve designer, right? So that they can interact with only small pieces. They don't have to really create a subset of it to be able to build a workflow that interacts quickly, right? So those, and then, on the right-hand side, it shows that all of those things, and then you could fire your jobs as we were discussing on any Spark cluster, right? And that cluster could be anywhere. And of course, all of this has to take care of things like impersonation, things like Kerberos, things like authorizations, things like authentications. So all of those have to be inbuilt pieces of the puzzle, because where there's data, there's security. Any questions? Okay. So connectors, so when you're running a streaming job, it starts running, right? And it's running forever, right? So, but in the designer mode, by default is that you don't want it running, right? You cannot, Spark context, hey, run, start, stop, and do the other one. That's too messy to control, right? So what we did was when the designer run it not in the streaming mode, but run in kind of a batch mode with immediate feedback and results, as we talked in 1-2 seconds for the user. So, so then run it in batch mode. Read the data, do this, and one of the big advantages of Spark, of course, that we all know and say that, well, you can build it for, have things between streaming and batch. It's not different, right? You could have it. You could write code which runs for both batch and streaming. So our designer runs in kind of a batch mode, so that it reads in a few records and then kind of creates the data frames and passes it on and things like that. So that was one crucial thing. So you have to build connectors that can read from this Kafka, few records, things like that, and pass it on and process. Or you have another, you cannot just use the off-the-shelf Kafka connectors for your designer and then have it running seamlessly. So yeah, so specialized code that runs in the workflow designer. We can have a full streaming job for interactive execution. So then coming to analytics, right? Say, so suppose you want to do analytics on your, what are the kind of things that users want to do, right? You want to do analytics. There could be different interpretations and variations of analytics. Some could be, well, I want to aggregate data and see the results, or hey, I want to, it could be aggregations, or it could be grouping, aggregations, all of those things, right? So this is showing that, allow the ability for the user to write Scala code, Python code, and SQL code within your workflows to be able to do it. We'll talk later on about, the performance and those things that come into play. So, and then, ability to allow the user to visually view the results of the aggregation. So whenever people are doing analytics, they want to be able to view it in different forms and ways. So, so that's where you could have heat maps, you could have charts, you could have geomaps, and those are the kind of things that come into play. So streaming visualizations, we did touch upon in the between. So streaming visualizations are interesting, meaning you have to have your Spark job producing those results that you're streaming it back into the browser. And in the browser, you have the ability to understand and keep moving the data. So what we used was, of course, use JSON to exchange data from the Spark job back into the server to the browser, to use JSON to be able to stream the data end to end, and to then finally show it in charts. So some of the things that we ran into when productizing this was, again, error handling came up very, very important. For example, you're doing a streaming job and say, hey, you are parsing certain records, and that parsing logic fails, right? So what do you do in those cases, right? So for example, of course, there's Spark CSV readers, which will kind of ignore. You could set it as options. But then what if you're getting it as a string, and if later on you're kind of splitting it by field by certain things, and that kind of fails, right? Or you expected an int, but it's not an int, and it's a string in different forms of ways, right? So what do you do in those cases? So in those cases, become interesting and challenging where, okay, this one is showing that there are good records and there are bad records. You need to be, okay, in your code, that one advantage is that you can keep improving your code that you write. So here are the good records and here are the bad records, and allow the user the ability to say what happens on error. Kill this job, right? Maybe you don't expect any errors and you kind of kill the job. Or you say, hey, ignore the bad records. Or you say, well, log these bad records, but log it here and keep going, right? So those are the hard scenarios in the real world that I ran across, that people asking, well, I'm coming from, say, data warehouse background, and these are very important. Data quality is so important. And handling those use cases becomes extremely, extremely difficult. I found that okay, I could build out these joins and this, but this was one thing that I found hard, that in doing when you're creating those jobs. So how many can you remember a case where you handled such a scenario, and how was the experience like? If anyone wants to share, would be definitely helpful for everyone. Like in the streaming job, you wanted to handle error of data. How did you go about doing it? What was the experience? Feel free to share. Right. And then you have certain configurations where it says go here, right? And then okay, so you push that error into, and then as you're running it at different times, you may want to do different things with it, right? And sure. Sure, sounds great. And the other thing is that as you are doing it, you want to be about performance. Like, you don't want to scan your data multiple times to say, hey, these are good records, these are bad records. So how can you do it only in one pass that can segregate it into two different good and bad records? So those were some of the hard problems that we ran into. How to do it when you're scanning it once. NLP we touched upon, suppose you are doing, another thing is we found that, people, open source, right? Open source, I mean, that's so powerful and important that integrating with more and more open sources and enabling makes it more powerful. Like if you look at NLP, OpenNLP, Stanford NLP are two. And of course, they are not built to run distributed by default. They have models. So then how do you configure, okay, here are my model files, right? And here is how you do, but then you have to make sure of serialization, right? Creating wrappers, making it serializable, and then making it serializable. So those are the things. Suppose you are doing name entity resolution, right? Or you are doing sentiment analysis. So then you could get those results. Right. So for the user, they're saying, well, I'm using sentiment analysis from here or here or here, and they're able to, without having to go through to do all of this, that makes it valuable for them. Streaming charts we talked about, how to stream the charts. I mean, whenever you're doing streaming charts becomes interesting because that's whether it is exceptions coming in or whether it is flights or whether it is, or whether you have patients checking in, right? Is the streaming analytics, what is happening over time, and being able to view it, it gets very powerful. So that if you can have multiple dashboards where, okay, you're able to display streaming of what's happening, that becomes a very, very powerful for the businesses. ML scoring is, of course, another where, okay, I have these models, right? And hey, whether they are pipeline models or others, can I go ahead and apply those models into the incoming data and score it, and then maybe see results on the score, or maybe store the score, right? So that's another very, very powerful one. And of course, in Spark, you could see that you could be doing clustering on the fly in streaming, where you are doing anomaly detections. So some of those codes are very interesting and hard to write, but making it available, say you're doing anomaly detections and you're doing constant or the moving cluster centers, but you're recalculating the cluster centers, right? So those things gets valuable for the end user to say, well, I could do anomaly detection with k-means on streaming data over here like this, right? So I'm trying to share here and go insights into how and where the value and how we can solve it. And then storing results, right? Suppose we're reading from different places, different connected to dog, okay? Go ahead and save it in HBase or here, right? I mean, those are valuable for the users. At the same time, one thing we discovered was in the designer, you don't want to kick off stores. Like suppose I'm processing and I'm storing somewhere in the designer. No, you want to protect the user from shooting themselves into the foot, right? So the processes have to be intelligent that where, how, where, they have to know the context. They not only have to know the processes around them, but where they are running now. Right? You may want to do a transform, so you're doing the serial result, but you don't necessarily want to write to, say, your HBase. You want to run it when it is actually running. So those are some interesting aspects when you deal with the stores of the data. So the next comes is the deployment and the monitoring piece of the section. So this is one value. For example, when suppose you're running many streaming jobs, right? And normally you would have a history server, right, where you're able to drill deep into it, right? But having a different kinds of views of it is helpful, right? For example, okay, I'm running this. Okay, what is the yarn application ID, right? And how can I easily go to, if I ran this, I know the context, so that I don't have to search it. Or, Yarn History Server provides a REST API, right? So how can you provide different views of the meaning of the jobs themselves to the users so that it makes sense to them? So tracking the job status, right? This is one thing we found was very crucial and helpful, right? If you're running jobs, is the job in the starting state, right, where it hasn't really started, it hasn't been scheduled, or it is right now in the running state, right? Is it running, and for how long it is running, right? Or is it completed? Well, in streaming jobs, it won't be completed, but has it failed or has it been killed, right? So looking at the status of the job is, and then to monitoring would be different ways. One is the job itself send a result back. That, okay, I am in running state, okay, because the less you poll, the better, right? Your system scales better the less you poll, right? Where the job itself is telling you, what am I doing? What state I am in? So it is much, much more easier. But what if the job sometimes just vanished and it wasn't able to tell the result as it was vanishing, right? So then you also go into polling, right? Say, for example, hey, this is running in this much state, but I haven't received a heartbeat from this in this much time. Let me go ahead and poll to find out what its real status is, right? So to do the polling on a more smarter and smarter basis kind of helps to scale the system a lot better. Maybe we don't know immediately. It takes maybe our time is, hey, I haven't heard back from it for 3 minutes. Then I go ahead and we found that to be pretty useful and make it configurable. So polling, it could be yarn polling, it could be span history service polling, you could poll it in different forms and ways depending on your cluster execution. But add intelligence of how you poll and when you poll. But use, it's sending you the status and the heartbeats. Relying on that is a very, very, very good method, right? So then the user knows, well, actually, I have received heartbeat from this in the last 1 minute. They will know what's happening, right? It's a much, much better view of things for them. So we discussed jobs per Spark, and then deployment execution. Suppose you're running different jobs to be able to go and say, well, these are the list of the jobs that are being executed, right? And being able to filter them, right? Or if you have one job, seeing for that job how many times it has executed in the past, right? Or how many versions of that is actually running, right? You want to know, well, of this flow, actually, are there multiple versions running at this time or not, right? So those things starts to make value to the user. That, hey, did I run it twice by mistake? Or is it running only one copy running? Or last time, what was its behavior? Look at the results, right? Okay, it actually died. Died with what exception did it die last time, right? So if I can quickly easily see what's the exception that it died last time, then it gives me some context. So it allows me to productize more and more of the jobs, streaming jobs, in production more easily. So yeah, I think deployment and execution, and the other is we talked about, pulling data all from different places. One thing people complain is I have to go a ton different places to get to know what my job is doing, right? I have to go to yarn, I have to go to a history server, I have to go to logs. I have to go to too many places to get a view of what is happening, right? So building such a system, the more value you provide where you integrate, read up the logs, read up the history server, read up the yarn, and to give a consistent view at one place makes it immensely valuable for the users. Another very important thing was scheduling and triggering, right? Suppose I have a job, well, it could be, hey, schedule this at this time. Right? I'll talk about, there are cases, use cases that, well, if the job hasn't received data for X minutes, stop it. Okay. I'm not saying it would be in all possible cases, but the many cases where people say, well, if you haven't received data for actually 15 minutes or X hours, you please stop yourself. So these are, again, coming back to what's the business real value, right? So, okay, go ahead and stop the job if it hasn't received data for X amount of time. So in which case, you could have, again, scheduling by time. So how can a user go ahead and schedule jobs quickly? Or the other is triggering, like, hey, poll some Kafka topic for triggering a job. Suppose you have certain events coming in and you want things to be triggered based on, that's something very useful that we found that people need. That you could be triggering it by an ID or UUID or those and say, hey, if I want to trigger this job, send an event to this Kafka topic, and I know that this job will get triggered, right? So you could orchestrate in that way. There's, of course, Airflow orchestrations or Uzi, and this is another way that anyone can say, oh, go ahead and trigger that job. They have more control. And for each of these, performance is always a key. So the workflow that we talked about, or self-serve, they have to be parameterized so that the user can see, well, trigger it off with these parameters, right? And so the other is that trigger it off with these Spark submit configurations. So having those parameterized and configurable is of extreme use to the users. Notifications and alerts, right? This is another very important one. Like, hey, if my job completed successfully or kind of failed, send a notification of this kinds, right? So, or it got killed, then send a notifications, right? So this is, again, operational pieces of the puzzle are very useful so that, okay, you have your email set up and SMTP, and so that or others, so that you get notified. So that's where the tracking the job status, it becomes very, very crucial, right? Suppose some job died, but through polling, you find out this one actually died. Did you send out emails or not? And then you follow through and send it out. That's useful for the end users who are running these complex systems, right? They could be running hundreds, thousands of these jobs. How do they manage and maintain it becomes a challenging job in operations. And he wants to talk about any other operational challenges and those things that you run into today. Sure. Oh, okay. So the question was, running the same or running too many? Oh, okay. Okay. Yeah. So, that's a very nice question. Thanks for that. So, helpful question. So, of course, if you have yarn queues, right? So being able to know who is the user, and based on the user, you are doing the queues and those things, right? So those goes into the configurations where, okay, your job is going into this queue. Okay, so then that is yarn providing those protections, right? Now you could say, hey, can I improve upon it, right? Then the administrator goes in and say, well, for a user, do not allow more than X jobs to be running at a time. So that's configurable, right? And then that you could be on a per group basis or kind of application basis or user basis. To say, hey, this group or any user, I don't want to be running more than X at a time. So make that configurable. And because all of these data get tracked into your database, they're already there. How many are running, which user, all of your data is there in your metadata store. Okay, so then it's very, very easy for you to say, okay, go this, apply this rule, and tell the user, you have actually 10 running jobs, you cannot run more. So having such a system makes it relatively easier to solve this problem. I'm sure there will be other problems that will be harder to solve, but this problem gets, because you have a database of users, their jobs, their groups, their permissions, everything, you have it tracked in your metadata relational store. Any other questions?
I have very basic questions.
Sure.
So this error handling, when you're saying during the error handling, you can separate these are bad data, these are good data. What is the definition of the bad data and good data when you need to scan 17 different lakes?
Sure.
Many different data subject areas as well.
Yeah. So let me give you an example, right? So the question was, if there's bad data, then do this. If there's good data, do this, right? So what is the definition? How do you even know what is bad or good data, right? So one is that, suppose, let me take a simple example where so one is, suppose you do the data validation up front, okay? That you say, I have these X, Y, Z and fields, right? And suppose you have 20 fields and this field is an email, right? And then you say this should have an email format, right? Another way you could say, hey, this should be a numeric in this range, right? So that is pure data validation, right? You have a node itself, a processor, which is validating your data upfront with high performance. So that is one. Another thing is that many times you have strings coming in, you're parsing, and you're creating ints, and they're not actually ints. Or you expected 10 fields, but there are only 8 fields. So there is a processor in which you define how you are creating your next data frame based on this data. Suppose you have one column line, and you want to now create 11 columns, line plus 10, 11. Now each of this did, one is a float. Did it even to float work or not? Or did it throw an exception? So that is another one. So it goes into writing it all for everything is very tedious. So, and not all of your processing logic will run into that. Provided you are doing schema properly. Like in a tool, you're handling your schema propagation and handling nicely, right? So then what we found is that less than 10% of the nodes where you really need to write this complex error handling scenarios they will run into. And if you find more, you continue to add to more of your processes or nodes. So that was our experience. Did it answer your question or something missed? Okay, so try to give you some examples. So each of these errors is actually a real case example. Or if you're doing certain things and
4 minutes.
Oh, sorry. So let me go quickly for a few minutes. Some interesting things that we run into, use case scenarios as you get building, right? Execution results. View and compare runs of different, various runs of a workflow. That is very, very useful, right? If you have run this 1,000 times or 300 times in the last 50 days, having those different runs and comparisons of the results gives you instant visibility, or even charts, or duration was this, right? Or exception was this. It gives you instant visibility into what is happening. So performance is a key, allow user control. For example, hey, I'm joining large data sets here, and I come up with something, well, I need to have, memory and disk serialization here, right? So for example, the persistence level, you need to allow user control. At the same time, give feedback, this is where you should change it, right? The other is Spark submit configurations, give them control, right? And then continue to update each node of your processor logic so that it is heavily, heavily optimized in the way, some of the examples we discussed, dedupe and others that we discussed of validation, which are hard. Error handling. Focus on the steps which took longer than expected, analyze the code, optimize it. Have continuous run load tests that are testing out your system, your different processes. Suppose you have 300 processes, you have load tests running of them, and you have data comparisons against those stores. So learnings, what is the end result, right? So more kind of users are able to use the system, right? It's not saying that, well, if you don't know this, or not into this, you cannot use it. So more variety of users can use the system, which is always good. Reduce time from idea to deployment. These days, with so many use cases come to your mind every week, or probably every day, right? When you have data, you have use cases in mind, right? This I could do, this I could do, this I could do. But how many can you actually do, right? It's hard because you have to build it, productize, see it, and maybe more than 90% you won't even productize it, right? So all of that effort will go into waste because you thought it was important, interesting today, but 1 week later it's not worth doing it, right? So much of work and effort gets wasted. Performance gets easier to manage. We talked about a lot of performance. Deployment becomes one click. You're able to run it instantly. Go ahead, do this, and run, right? Easier to write complex modules. Say how you can write you may change data capture. change data capture so many kinds into Edge-based, into Cassandra, into others, into Hive. It's very, very complicated, where many times we end up spending 50, 60, 70% of the time on change data capture, right? So without streaming a batch, right? So if you all the time is saved, that becomes very interesting. So what's the time? Oh, we are getting on, sorry. So any last minute questions, thoughts, and ideas? Oh, okay, sure. So we went ahead and built all of this, so I can share my experiences. So we built it on Spark, and there's a web server layer, and there's a relational database layer in which all is shared, and then there's a browser, and there are web sockets for like suppose a job is executing, how the results get displayed. So we use the power of Spark to do everything, and then built out this whole layer. Like if there are 300 processes, code for each of those, execution engine that executes your workflow, right? And executes your workflow both in your editor and in your batch. And then very heavy build out of the UI layer. That's probably 60% of the thing or even more. But the UI where there's interactive execution and schema propagation, schema inference, and users, groups, roles, permissions, that's a very, very big and heavy layer of it. So I'm trying to share, because we built it out, spent 3 years building it out, so I'm just trying to share my experience and love to answer any deep questions which I may not have. But so there's a heavy UI layer, there's a heavy engine and processes layer, there's a heavy security layer of the whole integrations, and then the interactions between, and then abstracting out as a framework, because it has to be a framework where the nodes can plug in and the UI can plug in, and the widgets around the UI, so that you have different kinds of widgets for node configurations. So did I answer some of your questions? I would be happy to meet you after this to dive into more details, if anything. Any other, sorry.
Probably, yeah, it's time. Probably more additional question, probably you can ask him outside. Is it okay?
So I'd really like to thank you for your time and the interactive questions. Thank you very much.
Thank you.